Hi everyone. So today we're going to continue talking about solving trigonometric equations. So just to recap what has happened so far this week, on Monday we started with examples of trig equations that you can solve without using a calculator, where the solutions are kind of nice angles that we're familiar with on the unit circle. In yesterday's video, we focused on solving equations where that's not the case, right? Where you have to use a calculator. And specifically in yesterday's video, we focused on solving using inverse sine. So we were doing equations where, the thing you were solving for involved sine of x is equal to something. So in today's video, now we're going to be focusing on using inverse cosine and inverse tangent. So we're going to be solving trig equations involving cosine and tangent. And basically we'll see that in a lot of ways it's a very similar process to what we did with inverse sine, but there are some key differences. And so before we get into those examples, I'd like to do a warm-up. So this is going to be something similar to what we were doing in yesterday's video, but I just think it would be good to kind of have that fresh in our mind so we can see how solving these other equations is both similar and different. Find all solutions to the equation 9 times sine of x minus 4 is equal to 0. So pause the video, try to do this yourself. You'll probably want a calculator handy, and then we'll go over it together. So how do we get started on this? Well, we want to start by isolating sine of x. That's always the first step in these types of equations. So we can start by adding 4 to both sides, and we get 9 times sine of x is equal to 4. And so that tells us that sine of x is equal to 4 over 9. So the next thing that we're going to do is just draw kind of a rough sketch, and it doesn't have to be perfect. It's just kind of like a reference so that when we're using the calculator, we have some visual idea of like what are the angles that we're actually finding, and that will help us to find the other angle that we need. So what does it look like if you have, so remember when you're solving sine of x equals 4/9, what that means is that you're looking for angles such that if you take sine of that angle, you get 4/9. That's what it means to solve that equation. So what does that look like? Well, it's going to be an angle with a y coordinate of 4 over 9. So what does 4 over 9 look like? It's basically a little bit more than half, right? Or a little less than half, because 4.5 over 9 would be 1/2. So it's a little less than half. So I'm just going to kind of eyeball it and go somewhere here. So this is one possible angle with sine equal to 4/9. And then if that's one of the possible angles, well, if you go to an angle that is just directly across from that angle, that has the same height, that would be another solution. So we can call this solution here x1, and this solution here x2. So the next step is that, unlike the ones that we did by hand, in this case, we really have no way of knowing what angle that is unless we type something into a calculator. So we're going to do inverse sine of 4/9 because, inverse sine of 4/9 is going to give us one example of an angle such that sine of that angle is 4/9. However, we have to make sure we're aware of which angle that's going to give us. So we know that inverse sine only gives us angles between -pi/2 and pi/2. So that means that the angle we're going to get by using inverse sine is going to be x1, right? Because x1 is like, it's definitely between 0 and pi/2. So that means that our first angle is going to be inverse sine of 4/9. And if you type that into a calculator, you get that that's approximately equal to 0.460 radians. So that's one of our solutions. And then how do we find the other one? Well, if you look at this picture here, this angle here is also the same number of radians as x1, right? Like that should also be 0.460 radians. And so if we do pi, so pi would be all the way like this, So if we do the orange minus the yellow, that will give us the green. So that will give us what x2 is. So x2 is going to be equal to, or approximately equal to, pi minus 0.460, and that is approximately 2.681 radians. Okay, so the last step, if we're trying to find all solutions, we need to also include any angle that is coterminal with those two angles. And so the way that we do that is we tack on the plus 2 pi k thing. So like I said, you can still write x1 and x2, or you can just say x. It doesn't really matter. So here we can say x is equal to 0.460 plus 2 pi k. So that plus 2 pi k part just represents the fact that you're saying I can add any multiple or subtract any multiple of 2 pi, and that will give me an angle that is coterminal with the angle the two angles I already found, and so those should also be included as solutions. So one thing I'm going to be emphasizing in this video, and I just want to mention it now, is that when you're asked to find all solutions, there's actually going to always be multiple different ways you could write down your answer. The important thing when you're finding all solutions is that these two answers that you give are not coterminal. So you can basically pick any two non-coterminal answers and then just add plus 2 pi k to them. And so in this case, I think the angles that we wrote down are really the most obvious ones, but we'll see some examples today where there really are kind of two different things you could write down, and either one of them would be okay if you're asked to find all solutions. If you're asked to find solutions specifically in a particular range, so the range you'll probably see is between 0 and 2 pi, well, then you need to be a little careful and make sure that you're giving angles that actually are between 0 and 2 pi. But basically, because there are always infinitely many solutions, and that's really what this part is telling you, there's just multiple different ways of expressing your answer. Okay, so let's get into an example with cosine. So this is where it's going to be really, really important that you actually sketch, make a rough sketch of the angle. And you might have at this point noticed a kind of a pattern with inverse sine, right? You might have noticed that you're always doing pi minus your first answer. And if you want to memorize that as a fact, that's fine. But what I would caution you against is, I think if you try to just memorize a rule, you might get confused when you go to do problems with cosine, because we'll see that exact rule does not work with cosine. And so rather than kind of forcing your brain to remember different rules for each trig function, if you just draw a picture and kind of use common sense and geometry, I think that's a much more kind of guaranteed way to get to the right answer. Okay, so we're going to solve basically the same equation, but with cosine instead. So find all solutions to 9 times cosine of x minus 4 is equal to 0. So we already know how this one goes based on the warm-up, right? If you isolate, you're going to get cosine of x is equal to 4 over 9. And so that means that we're looking for angles on the unit circle where the x coordinate is about equal to 4/9. So it's not going to look terribly different, but again, we just still want to kind of sketch it. So, or at least the first angle isn't going to look terribly different. So if we want an x coordinate of 4/9, that means that we want an x coordinate that's a little bit less than halfway between 0 and 1. So I'm going to go like here. So here's our angle. This is one of the two angles that is not coterminal. So what about for cosine, what's different? Well, the other angle that's going to have the same cosine value, it's not going to be over here. Why is it not going to be over there? Well, because with cosine, we're looking for the x coordinate to be 4/9. And so where on the unit circle would we see another angle with the same x coordinate? Well, it would actually be down here, right? Like that's a point on the unit circle that has the exact same x coordinate as the first one we drew. And so you could measure this angle two ways. I'm going to choose to measure it like this instead of as the negative angle, but we'll also talk about what it would look like if you measured it as the negative angle, because either one would be okay as long as you're looking just for describing all solutions. Okay, so how do we find these angles? Well, same deal with the previous example we did. So we have to start by using, in this case, inverse cosine. So we have to be careful, figure out like which of these two angles are we going to get by using inverse cosine. Well, remember, inverse cosine looks in this part of the unit circle. So inverse cosine only gives you angles between 0 and pi. And so that tells us that x1 is going to be the angle we're going to get when we use inverse cosine. It's not going to give us this angle x2 because that angle is not between 0 and pi. So if you type inverse cosine of 4/9 into your calculator, you will find that that is approximately equal to 1.110 radians. Okay, so how do we find the other angle? Well, let me tell you how we don't do it. If you do pi minus 1.10, that's not going to give you remotely the correct angle. So that's why I'm saying don't just try to memorize a rule. Look at your drawing and try to make sense of it. So, what's kind of the difference between these two angles? Well, notice that this angle here is also x1, right? It's the same number of radians. If you're not thinking about positive or negative, but just literally like the size of that angle is going to be the same number of radians as the size of x1. So how would we use that to figure out what x2 is? Well, in this case, if we do 2 pi, so 2 pi would be if we went all the way around the unit circle. If we do 2 pi minus the yellow angle, which is x1, that will give us x2. So we're going to do 2 pi in this case minus, and I guess I should say approximately equal to because we are rounding things. Oops. 2 pi minus, and then the yellow angle we have there is 1.110 radians. And so if you type that into a calculator, it will tell you that that is approximately 5.173 radians. So again, to find that second angle, we're just using geometry. We're just kind of making sense of, if I know this angle and I know that that all is 2 pi, how do I find the remaining angle? That's really the best way, and the way that I think most shows understanding rather than just trying to memorize some rule that doesn't work the same for every situation. So how do we then write down, all solutions? Well, again, we just tack on plus 2 pi k. So our solutions would be x1 is equal to 1.11, or sorry, I keep forgetting approximately equal to 1.110 plus 2 pi k. And then the other one would be, or I guess to be consistent with what I did before, I'll just say x. And then x is equal to 5.173 plus 2 pi k. So that would be our answer for all solutions to this equation. I want to point out that there actually is a different solution that is, kind of equally obvious that you could write down instead of this. So when we found x2, we measured it by going around, we measured it as a positive angle, right? But you could have also measured it like this instead. Let's call that x3. And that would also work, right? That angle is also a solution because it's coterminal with x2. x3 and x2 are not the same angle, but they're coterminal. And so either one of them is a valid solution. So you also could have said, well, x3 is basically equal to the negative of x1, right? Because it's the same kind of amount of angle, it's just going the opposite way. So you could say that was negative 1.110 radians. So another completely valid solution would have been to say, as your first solution, x is approximately equal to 1.110 plus 2 pi k, so that's still the same first angle. And then for the second one said x is approximately equal to negative 1.110 plus 2 pi k. So either of these two solutions that I'm putting in a box, these are both totally fine if you're asked to find all solutions. And again, it's because of this plus 2 pi k, and I think this is probably kind of a trickier concept, but the idea is that this plus 2 pi k is really kind of, it's representing all coterminal angles. So because the green and the purple angles are coterminal with each other, it doesn't really matter which one you're writing down. And I guess maybe just to make it really concrete, if you were to take the purple angle and add 2 pi to it, you would get the green angle. I would encourage you to try that. To take negative 1.110 and add 2 pi to it, you'll get the green angle. So it's really kind of, this 2 pi k is kind of giving you the freedom to write down any two angles that are not coterminal with each other as your initial solutions, and then you just say plus 2 pi k to represent the fact that you want all coterminal angles. However, big warning. So as I mentioned in the previous video, on the homework, it's specifically asking just for the solutions between 0 and 2 pi. So on the online homework, you are not writing this plus 2 pi k stuff, right? You're just giving two specific examples of solutions between 0 and 2 pi. If on the online homework you wrote these down, that would not be correct because negative 1.110 is not between 0 and 2 pi. So on the online homework, you would want to write these as your two answers specifically. And why am I doing it this way if on the homework it's that way? Because I think actually both are good to understand. And like I said, I think the most important thing to me with this stuff is that you can understand it in a way that's not just memorizing a procedure. And I think by kind of asking you to answer the question in all sort of slightly different ways is a really good way to make sure that you're actually understanding it. Okay, so let's do another one. So this one is going to be, so we're going to solve 4 times, so we're going to find all solutions, first of all. To 4 times cosine of x plus 3 is equal to 0. So first step, like the other one, is to start by isolating cosine. So we get 4 times cosine of x is equal to negative 3. And then we divide both sides by 4 and we get cosine of x is equal to negative 3/4. So let's draw ourselves a rough sketch of this situation. So we're looking for angles where the x coordinate is negative 3/4. So what's the first angle where that's going to happen? Well, let's see. So negative 3/4 would be maybe like around here. So that would give us an angle here. So this is our first possible angle. And then where are we going to have another solution? Well, if you go to an angle that is just kind of directly across the x-axis, that's going to be another answer. And so again, let's measure it in the positive direction. And the reason I'm doing them in the positive direction is because I think that aligns better with your online homework where you're supposed to say things between 0 and 2 pi. But just like on the last one, if you wanted to, because we're finding all solutions, you could measure it this way instead and write it as a negative angle and write your solution down that way. Okay, so how do we find these angles? Well, if we do inverse cosine of negative 3/4, that's going to give us one angle. And again, because inverse cosine looks in this part of the unit circle, it's going to give us x1 as our angle. So x1 is going to be equal to inverse cosine of negative 3/4. And if you type that into a calculator, that's approximately 2.419 radians. So how do we find x2? Well, again, it's going to be the same kind of pattern that happened on the last one. So this angle here is also the same measurement as x1. It's also 2.419 radians. So if we were to go all the way around in a circle, that would be 2 pi. So if we do 2 pi, so if we take the full circle of rotation and we subtract out the yellow part, that leaves us with the green part, right? Like the orange minus the yellow leaves you with the green. And so that tells us that we can find this angle by doing 2 pi minus what we found for x1. And so if you type that into a calculator, you get that's approximately equal to 3.864 radians. So how can we write down our solution? For all solutions, we want to then add 2 pi k to each of those. So we would say x is approximately equal to 2.419 plus 2 pi k, and then x is equal to, or approximately equal to, 3.864 plus 2 pi k. And just like in the previous example, if you wanted to, again, you could have measured the second angle as a negative angle. And that would have been then, so that if you were to write your answer that way, you would have your first answer being this, same one as before, and then your second answer would be the negative of that, and then plus 2 pi k for each. So I'm not going to write that down, but again, that would have been a totally fine answer if you were looking for all solutions. If you're looking for just the solutions between 0 and 2 pi, like on the homework, these would be your 2 solutions, because those are the 2 angles that are actually between 0 and 2 pi. Okay, so those are the 2 examples we'll do for cosine. I want to now look at some examples of using inverse tangent. Okay, so first example I want to do is we're going to find all solutions to 4 times tangent of x minus 10 is equal to 0. So let's start by isolating tangent. So we would get 4 times tangent of x is equal to 10, if we add 10 to both sides. And then we get tangent of x is 10 over 4, which can be reduced to 5 over 2. So one thing I just want to point out, you might look at this and say, wait, this number is bigger than 1, right? 5 over 2 is 2.5. That's a number that's bigger than 1. Is that okay? And it is, because we're working with tangent. So remember, sine and cosine are always between -1 and 1. Why is that? Well, because sine and cosine correspond to the x and y coordinate on the unit circle. And you can never get an x or y coordinate on the unit circle that is bigger than 1 or smaller than -1. However, tangent is taking the ratio of 2 of those numbers. And so it can be bigger than 1, it can be smaller than -1. Tangent can actually be equal to any number. Basically, the range of the tangent function is all real numbers. So what would this look like on the unit circle? And this one might be a little harder to eyeball, but we can still make kind of a rough estimate. So how can you visualize tangent on the unit circle? Think of this number as being the slope of the little line segment you're going to draw on the unit circle. So what does a slope of 5/2 look like? Well, it's steeper than 1, right? Because 2.5 is a bigger number than 1. And it's also positive. So, I'm just going to draw something like this, right? A slope of 1 would look like this, would be at like 45 degrees. And we know it's bigger than 1, so I'm just drawing something a little steeper than 1. And so this is one possible solution. This is x1. So where else on the unit circle are we going to have an angle that has that same slope? Well, if we just extend that same kind of direction into quadrant 3, that's going to give us another angle that would work, right? Because the slope is still positive. If we were to draw an angle that was here or here, those ones would have negative slopes. So those are definitely not going to be where our answer is going to be. Okay, so just like in the last few examples, we're going to use inverse tangent to find the angle. So inverse tangent always gives you angles between pi over 2 and -pi over 2. It's basically the same part of the unit circle as inverse sine. So that means that we're going to get angle x1 when we go and type inverse tangent into a calculator. So x1 is going to be inverse tangent of 5/2. And if you type that into a calculator, that is going to be approximately equal to 1.190 radians. Okay, so how are we going to find this other angle? Well, looking at the fact that these are kind of straight across from each other, right? They're like a direct line from one to the other. That means that you can get from this angle to this angle by just adding pi, right? Pi is 180. So if you take an angle and you add 180 to it, that means you're kind of just making a straight line across from your original angle. So our second angle is going to be pi plus 1.190. And so that's approximately 4.332 radians. So when we actually go to write down our answers, and this you might remember from when we did the video earlier this week, where we were also working with tangent, you actually don't need to write both of these down. And the reason is that because the period of tangent is pi, if you're trying to find all solutions, you don't need to write down both of these. You can just say one of them plus pi k. And it doesn't really matter which one you pick, but the more kind of standard thing to pick would be to say x is equal to 1.190, so the first one, plus pi k. So why is that a sufficient answer? Why don't you have to write down both of them? Well, because if you take the original angle, the blue one, and add pi, you get, oops, that's not the color I wanted. If you take the original angle, the blue one, and add pi, you get the green one. If you add pi again, you're back to being coterminal with the blue one. If you add pi again, you're back to being coterminal with the green one, and so on. So you're really, by saying plus pi k, that's going to give you all of the angles that are coterminal with both of those two angles. Again, just to give a shout out to the online homework, on the online homework, they're not asking you for all solutions, they're asking you for the solutions between 0 and 2 pi. So on the online homework, you actually would need to write both of these two that we found up here. So on the online homework, they're asking for all the answers between 0 and 2 pi. So that would be both of these two angles. But if you're just trying to kind of summarize all the solutions in the most concise way possible, then you would write what is circled down here. So maybe let me just add a note here. So online homework, and then I'll say this is all solutions from 0 to 2 pi. Okay, one more example. So last example is going to be -5, I should write down, find all solutions. To -5 times tangent of x minus 1 is equal to 0. So we can start by isolating tangent of x. So we get -5 times tangent of x is equal to 1. And then we get tangent of x is equal to 1 over -5, which is the same thing as -1/5. So that tells us that we're looking for angles on the unit circle with a slope of -1/5. So roughly what's that going to look like? Well, first of all, it's going to be negative. And second of all, it's going to be a less steep line than we drew in the last one, right? Because -1/5, that's a slope that is much less than -1, or you have to be careful with how you say that with negative numbers, but it's less steep than -1. So one possible thing might look kind of like this, right? An angle that is just kind of a not very steep negative angle. And then you would have another angle with that same slope over here, right? Like directly straight across from it. Both of those have a negative slope, not very steep, could be -1/5. Okay, so notice I didn't put any arrows on this, and I did that for a reason. It's because we have to be careful in situations like this with the types of answers that inverse tangent is going to give us. So again, inverse tangent gives us angles between -pi/2 and pi/2. And it specifically, if you have an angle like this one, it's going to give it to you as a negative angle. So that means that we should be measuring this angle this way in order to kind of have an accurate representation. And then x2 we can kind of choose, but let's measure it this way because it's generally preferable to measure things as positive angles. So if you type into a calculator, x1 is equal to inverse tangent of negative 1/5. Negative 1/5 is approximately equal to negative 0.197 radians. And then how do we find the angle in green? Well, that would be this angle, the blue angle, sorry, plus pi. So even though the blue angle is negative, it will still work to do that plus pi. And the reason is that basically, it's like you're subtracting the blue angle from pi, right? And so this angle here is the same size as the blue angle. And so if you do pi minus that amount, that's going to give you the green angle. And so in other words, we're basically just doing x2 is approximately equal to negative 0.197 plus pi. So you're just adding pi. And that will always work for tangent because the period is pi. So you would get the second angle equal to 2.944. So you might be wondering, why do we even bother writing down both of these angles? And it's true. So for inverse tangent, for equations involving tangent, if you're asked to find all solutions, you really only need to find one. And after you find that one, then you just say plus pi k. So a perfectly good solution to this would be x is equal to negative 0.197 plus pi k. So why did I do both? Well, because I wanted to, again, give you a little bit of practice with finding all the solutions between 0 and 2 pi. However, we're actually not quite there for finding all the solutions between 0 and 2 pi. And why is that? It's because this angle is not between 0 and 2 pi. So on this, on this specific example, I actually want to kind of write that down as a separate question. So if we were asked to find all solutions on the interval from 0 to 2 pi, so that means all solutions between 0 and 2 pi. So we have one, that's good, right? This one is fine. That one is between 0 and 2 pi. But the one that we found up here is actually not between 0 and 2 pi. So how would we kind of convert that into an angle that is between 0 and 2 pi? Well, that would be if we instead measured it this way. So how would you measure this angle this way? So maybe let's call this x3. That angle would be, sorry, I'm just trying to move, okay. That angle would be 2 pi plus x1. So I'm going to write that down and then I'll explain where that's coming from. Or in this case, sorry, I was trying to get creative with color, but let me go back to this. So it's 2 pi minus 0.197. So where is that coming from? Well, it's coming from the fact that, again, just kind of looking at the unit circle, this angle here, if you went all the way around a circle, would be 2 pi. This angle here is kind of the difference between the orange and the purple angle. And so if you do the 2 pi minus the yellow amount, you'll get the purple angle. And so what is the yellow amount? It's this. It's the same thing that we already found earlier for inverse tangent. So that tells us that, and this one I did already calculate this. So this one is approximately 6.086 radians. So if you were asked to find only the answers that are between 0 and 2 pi, these would be your two answers. This one and this one would be answers between 0 and 2 pi. So basically what you're doing is you're giving, for the one in purple, you're finding an angle that's coterminal with this original one we found, but it's a coterminal angle that actually lies in the part of the unit circle we're asking for. And it would be totally valid, by the way, for, I could ask you instead, find all answers between 4 pi and 6 pi, or between 8 pi and 10 pi. It's still always the same idea. It's that you're kind of taking your original angles that you found and then finding angles that are coterminal with them that happen to lie in the part of the unit circle that the question is asking about. All right, so that is it for today. Hopefully you'll take a look at today's worksheet, which will give you more practice with these types of problems. And yeah, that's it for this week. So I will see you all next week.